Imagine a world where your smartphone is as powerful as a supercomputer, where artificial intelligence can fit in your pocket, where virtual reality feels as real as the world around you. This isn't science fiction, folks. It's the promise of 3D integrated circuits, and let me tell you, it's mind-blowing. 3D ICs are not your grandpa's computer chips. They're a revolutionary leap in microelectronics. Think of them as skyscrapers of silicon. Instead of spreading out, they go up. This simple change is set to transform our digital world. More power, less space. That's the game changer. Now let's dive into the nitty-gritty. How do these 3D ICs actually work? It's simpler than you might think, and way cooler. Traditional ICs are flat, like a single-story house. 3D ICs, on the other hand, are more like apartment buildings. They stack multiple layers of circuitry on top of each other, but it's not just about piling things up. The real magic happens in how these layers connect. They use something called through-silicon vias, or TSVs. These are essentially tiny elevators for electrons. They allow different layers to communicate directly. No need to go around the block, it's a straight shot, up or down. This vertical integration is the key to their power. The manufacturing process is a feat of engineering. It involves thinning silicon wafers to mere micrometers. So what makes 3D ICs so special? Why are tech giants falling over themselves to develop this technology? Well, the advantages are nothing short of revolutionary. First and foremost, there's speed. In the world of computing, speed is king. And 3D ICs are the new speed demons on the block. By stacking circuits vertically, we dramatically reduce the distance signals need to travel. It's like taking the express elevator instead of running up the stairs. This translates to faster processing speeds and lower latency. But speed isn't the only trick up their sleeve. 3D ICs are also champions of energy efficiency. By shortening signal paths, they reduce power consumption. This means longer battery life for your devices. Section 4, Real-World Marvels, Current Applications of 3D ICs. Now, you might be thinking, this all sounds great, but is it just theoretical? Not at all. 3D ICs are already making waves in the real world. Let's take a look at some current applications that are pushing the boundaries of what's possible. First up, we have high bandwidth memory, or HBM. This is a game changer for graphics processing and AI. HBM stacks multiple layers of memory chips, connected by thousands of TSVs. The result? Memory bandwidth that's orders of magnitude higher than traditional solutions. This technology is already being used in high-end graphics cards and AI accelerators. Next, let's talk about mobile devices. Apple's A14 Bionic chip, used in the iPhone 12, incorporates 3D packaging technology. This allows for more transistors in a smaller area, leading to improved performance and energy efficiency. Section 5. Peering into the crystal ball future potential of 3D ICs. Now let's fire up the imagination engines and look to the future. What wonders might 3D ICs bring us in the years to come? Strap in because the potential is truly mind-boggling. First, let's talk about artificial intelligence. 3D ICs could be the key to creating true artificial general intelligence, or AGI. By integrating massive neural networks with high bandwidth memory and specialized processing units, we could create AI chips that mimic the 3D structure of the human brain. Imagine AI assistants that truly understand context and nuance, or autonomous systems that can adapt to any situation. In the realm of quantum computing, 3D ICs could play a crucial role. Quantum computers require complex control circuitry and extremely precise environmental control. 3D integration could allow us to pack all of this into a more compact and efficient package. Bioelectronics is another exciting frontier. 3D ICs could enable the creation of incredibly sophisticated implantable devices. Imagine neural interfaces that can restore sight to the blind or movement to the paralyzed. Section 6. The big picture, 3D ICs and the future of computing. As we wrap up our journey through the world of 3D ICs, let's zoom out and look at the big picture. What does all this mean for the future of computing? And more importantly, what does it mean for us? First and foremost, 3D ICs represent a paradigm shift in how we think about computing. For decades, we've been constrained by the two-dimensional nature of traditional chips. 3D ICs break us out of that flat world. They open up a new dimension, quite literally, in our quest for more powerful and efficient computing. This shift has profound implications for every aspect of technology. Our devices will become more powerful, more energy efficient, and more capable. But it goes beyond that. 3D ICs could enable entirely new categories of devices and applications. Things we can barely imagine today could become commonplace.